Hello. Today I'm going to answer the question of why we should define a number to the power of 0, got over this side, a to the 0. Why should we define it to be equal to 1? Most people who see this for the first time in Algebra 2, say, in maybe 10th grade, wonder why not say that a number to the power of 0 is 0? Why make it 1? It doesn't seem to make much intuitive sense. The answer is actually pretty simple. That's the question. The answer is because we need new, different exponent rules. Otherwise, I don't think I would like to memorize more exponent rules than I have to. And the major exponent rules that you probably know are these. That if you take a number a to the power of m and you multiply it by a to the power of n, that's equal to a to the power of m plus n. Another one is if you have a to the power of m divided by a to the power of n, that is equal to a to the power of m minus n. There's the first one, there's the second one, and there's a third one. It gets grouped in with these two. If you take a to the power of m, and you raise that to the power of n, then that's equal to a to the power of m times n. Now in other videos, I will explain why these rules actually make sense. But in this one, I'm assuming that you know that they exist, and I'm also assuming that you agree with the premise of my answer here. I wouldn't want to create new rules that are different than these that would only be applied when I look at a to the power of 0. I want these rules to continue to work. And so here is the real application of these rules that shows why. So for example, if we take a to the power of 5 and we divide by a to the power of 5, then we have two ways that we can evaluate this. Way number one is just to say, obviously, a number over itself, a to the 5 over a to the 5 is equal to 1, because that's what's always true when we take some number and divide it by itself. So that's just one way to solve this. But a second way is to apply rule number 2. And if we apply rule number 2 says if you have a to a power over a to a power, that's supposed to equal a to the difference between the powers. A to the 5 over a to the 5 is supposed to be a to the 5 minus 5. And notice that 5 minus 5 is 0. And so what we have here is a proof, in a way, that we have to define this in order for our rules to continue to work. We have here that a to the 5 over 5 is supposed to be a to the 0, but it's also supposed to be 1. And so these two things must be equal to each other. That's the answer to the question of why is a to the 0 equal to 1. You should memorize it. You don't have to think through these things, but that should give you some reassurance that this rule actually makes sense. Hope that helps.